Hello everyone. Previously we are done with the solid principles. Also we went with DRY, YAGNI and the KISS principles as well, right? Coding principles as well as the design principles. System design. Basically that's related to the system design. So now what we'll do as we are done with that part mainly, so we'll be discussing around 120 algorithms, right? So which covers most of the this thing, DSNA, right? So basically algorithms part, right, in simple terms. So first what we'll do, let's start with the array algorithms. So I'll be starting with the cadence algorithm. So we'll be covering all the topics basically. Very we will go with every algorithm that we need to know. So we'll not considering any important ones, non-important ones, no. So we'll be covering almost all the this one important algorithms, right? So now let's go with, there are some 100 plus algorithms. So we'll be considering every algorithm every day. So every single day we'll be covering one algorithm, right? So now, so array algorithm, first topic will be array algorithm, next second will be covering string algorithms as well. So some of them array, it consists of the cadence, prefix, sum, spread, this one sliding window, merge intervals, it can be anything. String kmp algorithm, z algorithm, right, suffix array construction. So these things will be going. Third topic will be sorting algorithms, fourth will be searching algorithms, and fifth we'll be going with the linked list algorithms, sixth stack and queue algorithm, seventh this one tree algorithms, as well as eighth this one graph algorithms, whether it may be Bellman Ford, Dijkstra's, DFS, BFS, Floyd Warshall, Johnson's algorithm. These things will be covering in the graph. So this one will be eighth. Kruskal's also, Kruskal's Prim's algorithm. So for the MST, so that one also will be covering. So and ninth will be this one dynamic programming. So 10th will be greedy algorithms as well. And finally, we'll go with number theory algorithms. 11th one, 12th one will be geometry algorithms. And final one will be advanced or the miscellaneous algorithms. When I say advanced or miscellaneous algorithms, we'll be going with this one, red black tree, AVL trees, whether it may be Morse algorithm on trees, right? So whether it may be subset enumeration, whether it may be persistent data structure, each one of the algorithms will be covering accordingly with the topic, right? Data structure topic, right? So first let's start with the array algorithms. We have some basically around um, 8 algorithms in the array. So let's start with the cadence algorithm first, right? So in the cadence algorithm, so first, let's go with the this one definition part. So here, what does the cadence algorithm state here? Cadence algorithm is a dynamic programming approach. So just keep this in mind. Cadence algorithm, what it is? It is a dynamic programming approach to find the maximum sum of a contiguous subarray in the array. Again, what is cadence algorithm? What does cadence algorithm state here? Cadence algorithm is a dynamic programming approach to find the maximum sum of a contiguous subarray in the array, right? So it efficiently solves the problem and big O of n time using the single pass. This is also very important, right? So it efficiently solves the problem and big O of n time using the single pass. So let's move on with the explanation part here. I hope the definition part is completely clear. It is just the dynamic programming approach to find the maximum sum of a contiguous subarray. So again, maximum sum of contiguous subarray, this part is very important, right, in the in an array basically. And also we have to keep in mind that this solves the problem in big O of n time using the single pass, right? Just keep that in mind. So let's move on with the idea or the explanation part here. So the idea is to scan through the array. We will be scanning through the array, nothing but the iteration part. And so we have to keep track of the mag, or we will be keeping track of the maximum subarray sum ending at each position. We will uh, track what we'll track, we'll be tracking the maximum subarray sum ending at each position, right? So first we'll be scanning through the array and we'll keep track of the maximum sum array, this one subarray sum that is ending at each position. I hope this is fine. Now at every index we have two choices, right? So this one I have found it relevant to explain. Basically, we at every index we have two choices. One is we can extend the previous subarray with the current element, right? So we can just extend the previous subarray, whatever the subarray that we have considered, we are considering currently, we can extend that one with the current element. So this is one thing. Or we can start a new subarray from the current element, right? So we will consider the previous subarray as previous itself, or we will be starting the current element with the next subarray. new subarray basically, right? So this one also we can do. We have two choices, right? Start as new subarray from the current element, right? So these two choices we can keep this in mind. So we will take the maximum of these two choices and we will update the global maximum. What we'll be doing, we will take the maximum of these two choices. We know the two choices, right? So we can extend the previous subarray with the current element. So the current element whatever we will consider or we are considering basically, so that one we can extend by the current element. We can extend the previous subarray with the current element, or we can start a new subarray from the current element. We can consider the new element as the new subarray, current element as the new subarray, sorry, and we can start a new subarray in this way as well, right? So these are the two options we have. So we will take the maximum of these two choices and then we will update the global maximum, right? So that's what we will be doing, right? So let's try to implement the exact same thing whatever we have discussed in the explanation part, right? So let's try to implement exact same thing via very simple example, right? So let's go with the cadence algorithm implementation. So I'll just go with def here cadence. So this one will be array. So this is fine within the Kadane function. So first, let's initialize the current sum and the maximum sum with the first element. So accordingly with the explanation, what we'll do, we'll initialize the current sum, the sum of the current subarray and the maximum sum with the first element, right? So I'll just go with max so far. So let me initialize that one to the first index, nothing but array of 0. Fine, simple. Now as per the explanation we have to go with another this one as well, another variable as well. So we have to store the maximum sum that is ending at the current index, that also we have to do. So I'll just go with current max. So this one will be array of 0. Simple, right? So let's move on with the next step now. So we are done with the first step. Let's move on with the second step. Now let's loop through the array that is starting from the second element, right? So let me write the simple if for loop here for I and range. So this one comma, so let me pass the array here. So this is fine. Now let's do one thing. Let's decide, so or we have to decide whether to extend the current subarray or to start the new one, right? So I can just articulate this one in the form of code in this way. Current max, this is max of iterated value of the array along with, so this one will be current max plus array of I, or the iterated value of the array. So what we are doing here again, so we are deciding, or we have to decide whether to extend the current subarray or we have to start the new one, right? So we are done with the step 3. So let's move on with the next step, nothing but we have to update the global maximum sum if needed, right? So again we have to update the global maximum sum if we have found the this one maximum sum, right? So if we have found the maximum sum, uh, maximum, it should be max, the value should be greater than the previous subarray, then only we have to update the global maximum sum. That is the reason uh, I have mentioned, I have said this one if needed, right? So we will be updating the global maximum sum if needed. So I'll just go with max so far. So this one will be max of let me pass max so far here along with the this one current max. So I'll just go with the current max. This is fine. Now we are done, almost we are done. We are left with only one step, nothing but we have to return the maximum sum that we have found, nothing but that will be stored in the maximum so far, right? So I'll just return max so far. So this is fine, we are done with the this one cadence algorithm. So let's go with the testing, or let's go with the example usage here. So I'll just go with array equals so this one, let me pass some random numbers, man. I'll just go with -2, -3, let me go with negative and positive numbers both. So I'll just go with 4, -1. So this one has to be I'll just go with -2. Again let me go with one positive number and one more positive number. Let me go with 5 or 6. I'll just go with 5 and let me go with -3 or something. Yeah, this is fine. uh yep, this is fine. Now let's print something for this one interactive purpose. So I'll just go with maximum subarray. So sum. So this one will be, let me pass the Kadane function here. So Kadane of this one, we have the parameter array, right? So let me pass the parameter array here. This is fine. So array we have already considered, right? So I have given some 8 elements, right? So I have passed -2, -3, 4, -1, -2, 1, 5, and -3. So the output that we need to get here is maximum, this one subarray is 7, right? So let me do one thing. Let me go with the control J here. So first thing, let me explain, and then or let me do one thing. Let me run the code. So then let me explain the output. So it will be correct actually. So I'll just go with the file name. Let me go with cadencealgo.py. Right, so maximum subarray sum that we are getting is 7, which is absolutely correct, right? So how? So we are passing -2, -3, 4, this one, -1, -2, 1, 5, and -3, right? So basically, just give me a second, 1 second here. Yeah, Cadence algorithm checks the subarray step by step. We know this one. We have already discussed the algorithm, and I have explained this one, and I have stressed certain parts as well, right? So the subarray, this one, what do we call? 4 as well as -1 as well as -2, comma 1, comma 5. So this one gives the maximum sum, right? So this one gives the maximum sum. You can just check, right? So this one gives the maximum sum. So see here, 4 minus 2, 4 plus 1, this one will be 5. 5 plus 5, this one will be 10. So we have to consider the contiguous subarray. Again, I'm telling we have to consider only the contiguous subarray or the continual subarray, however you call. We have to consider contiguous subarray. We cannot consider 4 and we can just directly consider 1 here. No. Else we will get the different output. So we can just go with this one, maximum subarray. We can just go with 4 plus 5, 9, 9 plus 1, 10, right? So only positive values we can consider, and then we can just print that one. No, also this is for the contiguous subarray that I'm speaking. So this one will be 4 minus 1 minus 2, 1 and 5. 4 plus 5, 9, 9 plus 1, 10, 10 minus 3 will be going with basically, right? So this one 7. This subarray gives the maximum, this one value within the array, right? So this is 7. So this one we have got here in the form of output. So the subarray, this one, 4 minus 1 minus 2, 1 and 5 will give the maximum sum, nothing but the 7. So the function, this one, the function is printing here. Kadane function is printing here maximum subarray 7, maximum subarray sum 7, right? So this is about the cadence algorithm. Very simple, right? So this is one of the important array algorithms, right? So we are done with the cadence algorithm. Let me summarize whatever we have learned so far, right? So cadence algorithm is a linear time algorithm for the maximum subarray sum. We know this one, right? So just keep this in mind. And also I have stressed this one during the definition part as well. So it uses dynamic programming, right? So cadence algorithm uses dynamic programming by keeping track of local and the global maximums, right? So this one we have discussed. This is also one of the important points. Just keep this in mind. And time complexity and the space complexity here, this one, let me write it here. So time complexity would be because of n. So I have mentioned this one already, and the space complexity would be because of 1, right? So time complexity would be because of n and the space complexity would be because of 1, right? I hope this part is completely clear, man. I hope this part is completely clear, right? So we are done with the cadence algorithm, right? So tomorrow we'll be discussing on the topic, this one, what do we call, prefix sum or the difference array, right? So currently we are discussing on the array algorithms. So we are done with the cadence algorithm. Tomorrow we'll be discussing on the topic prefix sum or difference array. For now, this is it. Thanks for watching, guys.